Okay, this problem is from Meat 1, Category 1, and it's a 5-pointer. The problem reads, the fifth power of a certain natural number is 1,419,857, and we have to find that number. So you can let x to the fifth be that number, and then we have to bound x. So 10 to the fifth is 100,000, and 20 to the fifth is 3.2 million. So we can write this. And when we take the fifth root of everything, we get which is pretty useful to know. So we see that the target number ends in a 7, which is pretty important because we can make a table of integers from 1 to 10 and what they end in when raised to the fifth. Okay, so 1 squared is 1 cubed. For every power, it's equal to 1. And then 2 is not 2. Whoops. 4, and then 8. And then it's 16, but we're just interested in the last digit. And 32, but we're still only interested in the last digit. So repeating this process for other numbers, I'm going to go kind of fast. Okay. So the only row we're interested in is the row of the fifth powers, and we see that only 7 when raised to the fifth ends in a 7. So we know that x ends in a 7. Since x is in between 10 and 20, we know that x has to equal 17, and that's just our answer. Yeah, so this problem had 2 steps, which was efficiently bounding x between 2 values, and then finding what it had to end in by ruling out other possibilities. So it was an interesting problem, but not really the hardest.